Good morning or good afternoon, it's Miss Bauer again, and today we're going to talk about Unit 6, which is all about quadrilaterals. Now, a quadrilateral is just a shape that has four sides. So any shape that has four sides, I'm just going to sketch one out. As long as those sides are straight, like that would be a quadrilateral right there. This is also a quadrilateral, because it has four sides. So any shape with four sides is just a quadrilateral. Now with quadrilaterals, we have some very specific shapes, which is what we're going to get into in this unit. So for example, a very specific type of quadrilateral is a parallelogram. And the key part of a parallelogram is that both pairs of opposite sides are parallel, meaning that this side is parallel to that side and that side is parallel to that side. That's the key attribute of a parallelogram. We also have rhombuses, and the key attribute of a rhombus is that all of its sides are congruent. So it's a type of parallelogram. So a rhombus is just a specific type of parallelogram with all sides congruent. We also have rectangles, which are another type of parallelogram, but with rectangles, all of the angles are congruent. And then we have a square, which is a specific type of parallelogram, which is also a specific type of rhombus and rectangle because it fits all of those properties. It has opposite sides parallel. Like the rhombus, it has all sides congruent. And then like the rectangle, it has all angles congruent. We also have some shapes that are not parallelograms. So for example, a kite. That's not parallel, so it's not a parallelogram, but this is just another specific type of quadrilateral. We have trapezoids that have one set parallel, and we even have isosceles trapezoids. So we have all of these different quadrilaterals in this unit, and specifically what we're going to talk about today is parallelograms and rectangles. So if we take a look at a parallelogram, the key attributes are that both pairs of opposite sides are parallel, meaning that this side is parallel to that one, and that this side is parallel to that one. So I'm going to draw some arrows on there just to show that those sides are parallel. Another key attribute is that the opposite sides are congruent. So I'm just making up numbers here. If the top would be 10 and the right side would be 7, well then the bottom would have to be 10 because the opposite sides are congruent. And if the right side is 7, then the left side should be 7. So it's a lot of part equals part in this unit with opposite sides. I also know that the opposite angles are congruent. So if I know that this angle over here is 80 degrees, well then the angle opposite from that would also be 80 degrees. And then if it's going to add up, so we've talked about like the whole thing should add up to 360. Well, then that means that the ones next to each other are supplementary. So that means that if they're next to each other, they should add up to 180. So if this is 80, then this one right here should be 100. And because that's 80, the one next to it should be 100, so it alternates. So we have 80, 100, 80, 100. And if I add all that together, I get 360. And I notice the opposite ones, so lots of rules here. Okay, I also know that the diagonals, if it's a parallelogram, the diagonals should bisect each other. So diagonal goes from corner to corner, from corner to corner. And when it means they bisect each other, it just means that if this is 5, then that piece right there should also be 5. Or if this piece is 6, then this piece over here should be 6. If this piece right here is 8, then that piece over there should be 8. And so if I told you that the whole thing was 12, then that's 6 and 6 because it bisects each other. So those are our main rules for parallelograms. Now let's take a look at the notes and we're going to do a few examples. So taking a look at parallelograms, we just talked about how the opposite sides are congruent and they're also parallel. So I'm going to say congruent, that's a symbol, and parallel. Key part of a parallelogram is that two pairs of parallel sides. That's our key feature of a parallelogram. If it has two pairs of parallel sides, it has to be a parallelogram. The opposite angles in parallelogram are, so think it was like 80 and 80, so the opposite angles are congruent. The consecutive angles are supplementary. Consecutive just means next to each other, so we just took a look at that. And then the diagonals bisect each other. And if we look at this example that they gave us, instead of putting numbers, they have markings. So like I see 3 ticks here, 3 ticks there, because those sides are congruent. 4 ticks on this side, 4 ticks on that side because they're congruent. The diagonals are split in half. I can tell by the matching number of ticks. And then I see the same number of arcs on opposite angles as well. So sometimes you'll see these little notations like the ticks or the arcs, and that shows that a shape is a parallelogram or something else as well. So if we take a look at this first picture or this first example, we have no picture. But I know that I have triangle ABCD, and I know that it's a parallelogram, not triangle. So I'm going to go ahead and sketch out a parallelogram. And it doesn't have to be perfect. But where I need to be careful is labeling. So as I'm labeling, I'm going to go clockwise. So I'm going to go A, B, C, D. And that's with every parallelogram. This rule wasn't that important with triangles because there were only 3 of them. So it'd be like A, B, C, or you'd swap 2 of them out. It wouldn't make that much of a difference. But with a parallelogram, I'm always going to start in that top left and I'm going to work my way around. I need to be really, really careful because where these angles are, if they're opposite or next to each other, that's going to change how I solve the problem. So we always start in the top left, so that'd be A. I'm going to go clockwise around, so A, B, C, D, and now I have my parallelogram. So if ABCD is a parallelogram, then it tells us that angle A is X and angle D is 2X minus 3. Well, if I'm looking at my picture, I notice that angle A and angle D are consecutive, or that means that they're next to each other. So if the angles are next to each other, or consecutive, if I go back, consecutive angles are supplementary. So if they're next to each other, I'm going to add these together and set it equal to 180. Now, what's kind of weird about parallelograms is the whole thing adds up to 360, but half of it will be 180. So be really careful. Are we looking at the half or are we looking at the whole? So I'm going to do part plus part. So I'm going to add 2x minus 3 plus x. And if I combine like terms, 2x and x would be 3x minus 3 equals 180. And now I'm just going to solve for x. So I'm going to add 3 to both sides. So now I have 3x equals 183. And then to solve for x, I'm going to divide both sides by 3. So x would equal 61. And that's it. That's how this works. Now, let's just say that it didn't say find x. Let's say that it told us to plug it back in. So I know that x would equal 61. If I do 2 times 61 and then I subtract 3, that's 119. But what if I asked you to find angle B? Well, remember that opposites are congruent. So if angle D is 119, then angle B should be 119. And if I wanted angle C, well, then angle A is 61. So the one across would be 61. And that's how this parallelogram works. Okay, now taking a look at another one, I don't have a picture, and that's okay. I'm going to go ahead and sketch it out. So this is now parallelogram XYZW. So I'm going to sketch out this parallelogram, being very careful to remember that we start in the top left corner and I go clockwise around. So X, Y, Z, W is a parallelogram, and then it tells me if I drew it correctly, I should have diagonal X to Z, which I do, and diagonal Y to W, which I do. Those are the opposite ones. And that they intersect at point A. So I'm going to call that point where they intersect A. So all I've done so far is just kind of read and sketch out. So if XYZW is a parallelogram, it has 2 diagonals. They intersect at point A. Okay, now X to A is 3M. So X to A, this piece right here is 3M. And then Z to A, this piece right here, is 5M minus 4. Now, because this is a parallelogram and we're talking about the diagonals, I had this rule back up here that the diagonals bisect each other. And I can also find it on this formula chart right here. The diagonals bisect each other. And what's nice is that you'll have this formula chart. So like you'll be given this formula chart for your assessments. So you don't have to worry about trying to memorize all of these rules. You just have to know how to use them. So if I know that the diagonals bisect each other, that means same number of ticks. It means that this piece is the same as that piece. These pieces are congruent. So this would be part equals part. So 3M would equal 5M minus 4. And I'm going to put the letter on the left, so I'm going to subtract the 5M, trying to get the letter by itself. So I'm going to move this over here. 3 minus 5 would be negative 2m equals negative 4. And then when I divide both sides by negative 2, two negatives make that positive. 4 divided by 2 would be m equals 2. And that's it. Now, if I went to go plug that in, so 3 times 2 would be 6. 5 times 2 is 10 minus 4 is 6. So this piece is 6, this piece is 6. The whole thing would be 12. Now, I don't know anything else. I just know that this is 6 and this is 6, but I don't know if those are the same. I can't find the outside pieces. I don't quite have enough information, and that's okay. Now, taking a look at our last one, they gave us a picture. So we have a picture. I just need to find these missing angles. So I like to start with the opposite rule. So if I know that this is 120 and I go across to the opposite, well then angle Z has to be 120 because the opposites are congruent. Okay, so I figured that out, but now I need to get X and I need to get Y. Well, if we remember, if they're next to each other, they're supposed to add up to 180. So if this angle right here is 120, 180 minus 120 is 60, which means that this whole angle over here should be 60 and that whole angle over there should be 60. Because if they're next to each other, they add up to 180. So if that's 120 and that's 120, the other two angles have to be 60 and 60. And if this piece is 35, ask yourself what plus 35 would give you 60, or 60 minus 35, and that tells me that X is 25. So now I just need to get Y. Well, a lot of people like to think of this like a triangle, and if that's 25 and that's 120, I can add and subtract from 180, but there's another rule with parallelograms, and it's that opposites rule. If this is 35, then that one should be 35. Remember that these were all parallel lines, so I'm having alternate interior angles here. So if this is 35, then that angle right there is also going to be 35. And it works the other way as well, that if this piece is 25, then that piece right there should be 25. It's that opposites rule again coming into place. So I'm just going to sketch out another picture. Let's say I had a diagonal here, and we said that this piece was 70. Well, then this piece over here would be 70. They alternate and they're congruent. Those are our main rules for parallelograms. We'll jump back in the next video to talk about rectangles.